Teraz jestem, tak jest. Cześć wszystkim, ja was nie widzę i nie słyszę, mam nadzieję, że wy mnie widzicie i słyszycie. Witamy po raz 67 na WrotQA. Z Vewd spotykamy się kolejny raz, tym razem w nieco innej rzeczywistości, odmienionej i cyfrowej, ale dla nich to chyba chleb powszedni, to obracanie się w cyfrowej rzeczywistości. Oferują przecież produkty, usługi wokół tego, wokół właśnie cyfrowych rozwiązań, więc myślę, że uda się to fajnie. Zresztą nie po raz pierwszy robimy WrotQA online'owo. Dzisiaj będą dwie prezentacje. Pierwsza będzie wokół testowania długich scenariuszy end-to-endowych, nie z poziomu UI, ale wykorzystując API, więc bardzo ciekawy temat, jak to można rozwiązać. Natomiast w drugiej prezentacji porozmawiamy troszkę o Cypressie. Zanim do tego przejdziemy, to tylko powiem, że kolejna WrotQA już niedługo, ponieważ już w planach mamy WrotQA 14 lipca, także zapraszamy serdecznie. Nadal będziemy w tej rzeczywistości online'owej. Niestety jeszcze i ograniczenia, i ta niepewność związana ze spotykaniem się na żywo jest zbyt duża, żebyśmy mogli zorganizować to wydarzenie live i zobaczyć się z wami wszystkimi, natomiast no, po cichu liczymy, że powoli zacznie wracać to do normalności. Dobrze, żeby nie przedłużać, jeszcze jeden ważny komunikat, pozwolę sobie przełączyć się na język angielski. So, for all of you that are non-Polish speaking, today's presentations will be both in English. So if you'd like to join us, if you're not speaking Polish, don't be worried, because both are run in English. Dobrze, to co? Myślę, że możemy zaczynać. Pierwsza prezentacja API Flow Tests. Poprowadzi ją Agnieszka Janiec. Tak jak mówiłem, opowiemy troszkę o automatyzacji ścieżek end-to-endowych bardziej przy użyciu API niż z poziomu UI-a, a ponieważ przykłady, które będą pokazywały nam, jak to można fajnie zrobić, będą w Pythonie, no to pomoże nam oczywiście Python Developer, czyli Piotrek Berezowski, który razem z Agnieszką poprowadzi tę prezentację. Zapraszam was do wysłuchania, popatrzcie, co fajnego Vewd u siebie robi w temacie testowania. Normalnie powiedziałbym, przywitajmy gorącymi brawami, możecie poklaskać do monitora, jak bardzo chcecie. No i co? I startujmy. Scena jest wasza, zaczynajcie. Aga, chyba cię nie słyszymy.
Sorry, guys. I hope you hear me now. So, very brief introduction. Piotr is our backend developer, our Python developer, who is actively supporting a quality assurance team when we are developing our automated tests. And I'm Agnieszka, and I'm a quality engineer in web services-based projects. And today we will be talking on how to integration test microservices backend using APIs. First, I will briefly explain what are API flow tests and how they are different from API testing. Probably many of you are familiar what API testing is, but API flow tests are not the same. And then I will also explain to you how we implemented those tests, because they started as an idea in Vewd, as a concept, but we also implemented this concept. So then Piotr will tell you more about technical part of our API flow test, how the architecture looks, how to write such a test scenario. We will also show you how to run such tests, what a report looks like. And yes, and that's the agenda. Okay, so I will start with how it all started. We used to have UI automated test written in robot and using Selenium. And those tests were growing and growing and growing, and they were overbloating. And at some point, we ended up having what's called like test cone, test stack shape. And at some point also, the maintenance of those tests was more costly than benefits from them. Each time we wanted to use our UI automation, we actually first had to fix tests. That's why we decided one day that, hey, how about instead of doing all this clicking via UI, which was really flaky, maybe we will try to do the same, like do what user would do via UI, but using APIs. I will show you an example of how you create such tests, how you map user actions to API flow test. But first, I will briefly explain on which part of project we will be doing that. One of the products we have is Vewd App Store. And the App Store contains video applications and also video content, like videos themselves. But before application can end up in App Store, someone needs to provide this content. And content owners have special panel in our UI when they can submit applications to us. Then our moderators have special panel in our UI when they can moderate applications after apps are approved for certain devices. Then they land in our App Store. And this is what the project structure looks like, and also where API flow tests are used in our projects. So basically, this is your typical web services-based projects. You have your clients. These are clients which, for example, have App Store like TVs, set-top boxes. Another client is our own UI. All our clients access microservices-based backend via API level. Now, important thing in this slide. We are using our API flow tests mostly between our UI and our microservices backend. And as you can see, we are using API flow tests using different APIs, for different APIs. Parts of the project have REST API, part of the project are using gRPC, and also if you want, you could be using API flow tests in here using the GraphQA requests. Now, why we have API flow tests? Because the microservices backend actually looks like this. And just component testing each microservice isn't enough. You really need to integration test your microservices. And this is what API flow tests are for. They are supposed to test microservices integration. So API tests, when we test API, we checked responses codes for valid requests, for invalid requests. We check if proper fields are returned in API response. We check if those fields have proper format, ints are ints, strings are strings. Then we usually prepare some mocked data, and we check if our API responses with appropriate data, appropriate values. And at the end, we usually do some end-to-end testing to check on entire living system if the API main requests are responding properly. Now, API flow tests are not intended to test API in details. And they are intended to test integration, and they are intended to recreate like long user paths through the system. Now, example of how to map user actions to API flow test. And we will be doing this example. Someone submits application to App Store, and then moderators need to moderate it so it can be shown in the store. I need to switch for a second. What I would like you to pay attention here is how many clicks you need to do this part in UI. And it will be only like part of the path. So first of all, we of course need to log into the system. That's already one reloading of the page. Then what we want to do as a user, we want to submit our application. As you can see, another reload, another place in the path when Selenium may go wrong. And then we start like submitting our application. And here you can see how many more tabs you have to go to, fill, and each time something will be reloading. That's like a lot of steps. And when we were trying to do all those steps via UI, it was super flaky. Because before you like finish all this clicking for all those tabs and submit your application, there is actually another place to go. Now we need to go to moderators panel. Since this is internal part of the system, I can't show it to you. In UI, you will have to believe me that moderator has similar path to go to. So it's like 12 reloads, 12 switches between different tabs, different pages, different panels in our UI. I think you can see now why it wasn't working so well. So what we did, we got rid of the UI. We decided that we'll be doing those long paths using available APIs. And this is how example API flow tests look like. We create application and pretty much send the same request as would be sent to our backends when user is clicking via UI. The entire logic, the request sending, this is in another layer that Piotr will be explained to you. Why it's in another layer, why this code isn't all here. Well, it's for readability, of course, because otherwise those tests have many steps and otherwise they would be super difficult to read. So we are submitting application. We are making sure proper metadata were submitted. Then our moderator starts their work. So you can imagine at this point in our UI, moderator in their panel are clicking some button like start moderation for this application. Then they check if application has appropriate content and approves the content quality. So that's another button click right here. And then moderator decides if application can be published on certain device or not, and approves it or rejects it. Here we are accepting application in this scenario. There's of course another scenario where we are rejecting application. And then our moderator is saying, that's my job is done. They are clicking. This is the moment when in UI, the user would click moderation done button. We try to name those steps pretty much as what would be happening in the UI for the readability of the test. And I will just show you one last thing, because those tests end in checking if application is actually available in App Store. It's like the entire long process we would do from submission to seeing application on device. Again, via API request, we check if our device is in proper category, in proper country, if API returns a proper response. And this is how we map UI actions to API flow test. Let me go back to the presentation. That we don't need. And now, a few things about API flow tests. First of all, it's not a ready-to-use framework. It's not a library you can download and use. It's not something you can install. As you probably already noticed from this example, AFTs are tightly coupled with your backend code. They need access to your internal APIs, like APIs between microservices, like, the communication between them. And you must be able to trigger events to propagate the data between microservices. So they have to be written per project. And in our case, for example, at Vewd, we have 3 versions of API flow tests. They share a common concept, they share common architecture, but they are slightly different. Well, the one obvious difference is that part of our systems are using REST APIs and some are using gRPC. So we have to separate those tests already. And also, as I already mentioned, API flow tests are a concept, actually, and you can choose how you want to implement it. Our implementation is just one of the possible architectures here. Can anyone write API flow tests? From my experience, not exactly. People like to hear that, oh, this framework is so easy that your grandmother will be able to write those tests. Not the case here, not. But it's not that bad. It's not a rocket science. However, from our experience, the entry threshold is junior level development knowledge and competence in at least one programming language. That's enough. Like, you don't have to be experienced programmer, but you do need to know how to code. Okay. So now, how do you implement such a framework and how much effort it took, what we learned during the process? Well, first of all, who is needed to implement AFT? Well, the one person who will say, hey, let's see if this solution will work for us. Let's see if we like it. Let's see if it's going to be helpful in our project. And this person needs to convince some other people to jump on board. Once we have initiator, we need to find the crew. First, what you need is architect. And it doesn't have to be like job description that this person must be an architect formally. You can find someone who is just passionate about it, someone who is maybe a member of architecture guild, or experienced backend developer who is known for their quality of code structure. So who can also help to prepare like proper, robust scaffolding for the test framework. Then, of course, someone needs to write those long scenarios. And you need test developers. Again, it doesn't have to be like formal job description. You just need people who are experienced enough in coding to be able to write those scenarios and who, of course, want to do it. So in our case, mostly QAs are writing them, and sometimes some developers also want to see what those tests are about, and they also try to write some scenarios. Then those two will need quality assurance specialist. This person is quite important here. because someone needs to decide what goes into API flow tests. These are tests which run on entire system, so entire system must be deployed. And those tests are somewhere here in our testing trophy. They are quite high. They are back-end end-to-end tests. So you don't want to put everything in there. You want to select what goes there, and this is a QA specialist role to tell where are your main business paths, where are your P1s, where are those paths 90% of the users will be going through, and this is what goes into API flow test. So basically, the test developers need to know what to automate in API flow tests. And QA specialist is telling them that. And all of this will not be possible without the DevOps team. Yes, infrastructure. These tests need isolated environment to run. And it doesn't matter if you have dedicated infrastructure team, if you call it infrastructure DevOps, or you just have someone in your own team who is passionate about it and can help with setting some servers you can use for your AFTs. The infrastructure is very important because those tests are invasive. They must be isolated because they are invasive. They operate on database, they clean database, they create their own data. So yeah, they need their own environment, definitely. And one more factor, it's cooperation culture. Creating such frameworks and tests, it's not like one-time job. Just give me a second. Those tests, they will need maintenance. They will need optimization for speed. They will, of course, need updates because new tests are added. And for that, you need like entire team to work together and help each other. And one last thing. As you can see, it is quite an effort to create such framework. So you need that person who has very good diplomatic and convincing skills, who will go to the management and convince them that those tests are actually worth an effort. For us, it wasn't that difficult because what we had at the beginning, those long paths done via Selenium in UI, wasn't working. So it wasn't that hard to convince anyone that we need something different and that we need to change. So we got that management support quite easily. And was it worth it? Yes, it was worth it. The API flow tests, they changed the way our test stack started looking. I call it test stack, you can call it testing pyramid, testing trophy, whatever shape it has. At the beginning, as I told you, we had something like test cone, we had too many UI automation tests, and then our stack started moving to more of a testing trophy shape. A lot of integration testing and minimize end-to-end testing. Also, API flow tests take much less time than UI automated tests, so we could use it in our CI. They are quick enough to actually be run continuously. What's also interesting is that they helped us to reduce the volume of our UI tests. Now we also have more robust UI tests because we don't do all those long flaky paths through UI anymore. Yeah, so for us, this concept of API flow testing paid off. And now I'm giving the voice to Piotr. He'll be talking about technical side of implementing such framework and show us like short demo.
Hello, everyone. I hope you can hear me and you can see my screen. What I would like to show you here is the code which is used in our API flow test framework. What you can see here is just an example test case written using our framework. It is built on top of PyTest, which is one of the most popular Python testing frameworks. So if you are familiar with PyTest, you probably know that each method or each function is treated as a single test case, which can be then grouped with classes and then modules and so on. So by default, when you run PyTest, it will collect all files with test prefix and then execute all functions and methods from those tests. And this is the default behavior. But in API flow tests, we want to test the whole end user scenarios. So the idea here is to treat the test class as a single scenario, and then all methods included in those classes are single steps, which are mapped to the UI actions, just like Agnieszka said before. So what we need to do first is ensure the proper ordering of those steps. So that's why we have this custom PyTest mark step here, which takes one integer argument, and these values are then used in our framework to sort those methods correctly, to have them executed in proper order. And another thing is that all test cases inherits from this base test blocks class, which I will show you now. And what we have here is this mappings between our functions and UI actions. Okay, I will. How to do this? Okay, now should be better. So as I said, what is here is basically the mapping between methods used in our tests and UI actions. So those methods are basically, in most cases, just API calls and then following assertions of the status codes or some data returned from those API endpoints. And another thing which is important here is that when we have those steps, they have different scopes. So we have to have some mechanism to share data between those steps. That's why we created this context dictionary here. So it allows us to save data in the context in one step and then use those data in following steps. It should be it is shown, for example, over here. We are creating application, and then everything returned from this method is saved in the context, which is used then in the next step. Yes, and this is basically two things which are building our base test blocks class. Why we did this that way? Because it makes our test cases more readable. It's just one method in each step. And of course, we can reuse this code between different scenarios. And a part of that, when there would be some AP changes, some payload will change. It will require a change only in one place in our code. Okay, so now let's move to the another part. Here, what I show you is conf test file. So if you were using PyTest before, you know that this is the main file with all configuration. And also PyTest allows us to customize some behaviors by overriding functions called hooks, which are executed in some point of the execution process. For example, before test is executed, or after, or when all tests are collected. And this is how we did. This is what we did in our framework. We just overrode those hooks. For example, here, this function is executed after PyTest collects all files, and here we are modifying order of tests to be executed. By first grouping them by class, and then sorting by the value passed in this step mark I showed you before. And here, those two hooks are executed before and after each method from test class is executed. So it is used to skip or fail steps which occur after the failing one. So here we are here if we have if we had some exception, we are informing the next steps that previous step failed, and there is no need to execute this step because the scenario already failed. Yes, and I think that would be probably all in this file. Also, as API flow tests are high-level end-to-end tests, they require the whole system to be up and running, just like Agnieszka said in her part of the presentation. So you have to deploy all services, message brokers, databases, and all other components. In our company, we use Kubernetes cluster for this. And the API flow tests are run against those clusters, those environments. So we have to somehow parameterize those tests to execute them against a correct environment. That's how we created this config class. We use environment package, which maps environment variables to these values in class, which can be then used during execution. You can also define some helpers methods, like, for example, here we are generating the URL for the endpoint, and this config is passed by fixture to the test cases. Yes, and as those tests are like I said, high-level end-to-end tests, they take some time to execute. In common case, one scenario can take like 5 minutes. We have 3 sets of the scenarios, each with like 10 or 15 test cases. So you can see how long it will take to execute them one by one. And it is fine if you want to run those tests like once or twice a day, but we wanted to put them in our continuous integration process. So it was too long to have tests executed over an hour. And what we did was to make those all those scenarios independent, so they could be run in the same time. And then by using PyTest plugin, which is called PyTest X dist, we can run them in parallel. What it does is just basically creating multiple processes, and then after collecting test cases, they are distributed between those processes and then executed in the same time. And this approach let us to reduce overall execution time from over an hour to about 8 minutes, which allows us to put them into CI. So this is important that if you decide to use API flow tests, try to make the scenarios independent from the beginning to avoid some problems in the future when the execution would be too long. And I think that would be all what I wanted to show you in the code. So maybe now I will show you how to execute those tests. So we are using Docker containers because it allows us to put the tests in the CI, and plus it's easier when you have a container with everything set up, and you have to just run one command to run those tests. So here I have this Docker Compose YAML file, which have all environment variables and PyTest command set. So all I have to do now is just type Docker Compose up, and the tests should be run in a second. Here, as you can see, PyTest X dist is creating processes, then distributing the test cases between those processes. And in a couple seconds, we should see some output. So let's just wait. Okay, so it takes longer than I expected. So maybe first I will show you, okay, they are running. So this is how the whole output will look like. So we have a status of the test step, which was executed previously, and what is the current progress of the tests. And there wouldn't be much more here visible in the CLI. So after the execution, there is the report created, which we map to the HTML file. and how it looks. This is how this report look. So here we have some information about environment and then summary of the report. I picked one execution which was failing to show you how it looks like. So here we have statuses of all steps, how many of them passed, how many failed, and etc. And then we have results of each scenario. Here we have some detailed information about the steps, like the name, result, and duration. And in case of fail, there is also stack trace included. Like for example, here you can see what went wrong. In this case, there wasn't a positive output of the step after 5 tries, so it failed. And then all following steps are with status X failed, because as I said, they don't need to be executed. Yes, and yeah, here we have there's already 27% progress. So we probably wouldn't be waiting whole 8 minutes to show you that they actually took 8 minutes. So I will stop this, and I think that's all what I wanted to show you. And we can go back to you, Agnieszka.
On this slide. Okay, so there was a question, how do you determine if you need API flow tests in your project or you don't? Okay, so the question was how to determine if you need API flow tests or not. The first question is, are you happy with your testing stack? If everything is going okay with it, then you probably don't need additional layer of testing. The second thing to ask is, how confident are you in your component UI unit tests? How confident are you in this layer? And there are some factors. So if you have monolithic type of backend, not microservices, and you are confident that the component test coverage is high enough and they are of good quality, you may not need API flow tests. If you have microservices backend, even when you have really good component tests, I would say go with the flow tests or any other version or backend integration tests. But for us, the API flow tests are a good version of microservices integration tests. The first thing to ask yourself is this part of your testing stack. This is end-to-end UI automation tests. How do you feel about them? Are they working fine? Are they short enough? Or are they giving you some headache? They are flaky, or the execution is too long. If that's the case, go with the API flow test. One more thing to ask yourself is a risk factor. If you have good component tests in microservices, for example, and you are okay with occasional problems with integration, and stakeholders are fine that something may not work in the end, then you may not need this layer. If you need more security, if you are not willing to take too much risk, go with those tests. Another factor to determine is how good is your production monitoring and how big is your user base. Because if you have great production monitoring, your stakeholders, and you have reverts from production, you can quickly do reverts from production, you have automated self-healing, so you see that, oh, okay, 1% of users are getting tons of errors, and the system is automatically returning to the previous version after deploy to production. And stakeholders are okay with taking this risk, then you may go without API flow tests. And that's basically those 6 factors to determine if you need them or not. Okay. A few more words as we are on the slide already. At our company, our test stack, the tests in it are complementary to each other. So remember when I said something about this cooperation culture? So it looks like this. QAs check components test. We actually review them, we check what's in them, we suggest developers what needs to be added. And that way, we know what's not necessary to cover in API flow tests, so we don't do double the job. And then again, almost all QAs write API flow tests and also know what's in them. So then it's easier not to write too many UI tests. Again, those are complementary to each other. And yes, and in a moment, so I didn't forget, our colleagues will be telling you something about this layer of our tests as we moved from Robot and Selenium to Cypress, and we've been using Cypress for some time. And the Dima and Christian presentation is coming after this one. And yeah, I think that's it on our API flow testing. I don't know if there are any more questions. I don't see, so I think we will be wrapping it up.
I guess we can give a minute or two for any additional questions the audience might have. So counting down from 3, 2, 1. No one's there. Okay. Thank you, Agi. Thank you, Piotrek, for your presentation, for showing us how to use this layer. Pretty interesting. Thanks a lot. All right. I guess we can move on to the second one. As previously already announced, we're going to be speaking, or rather, Dima and Christian are going to be speaking about Cypress, how they use it in Vewd. They say it's a new tool in their team, so they are still learning its limitations. But they're going to tell you why they decided to use it, how they use it, what limits it has in their context. So please welcome on stage Christian and Dima. The scene is yours.
Okay, hello everyone. I will start with my presentation first. You can let me know once you see it. Okay, so today we are going to be talking with Dima about Cypress IO at Vewd. This will be mostly an introduction to Cypress type of presentation and to share what we found out once we started implementing Cypress in our company. So, who are we? I'm Christian. I'm a QA in the software updates team in Vewd. And on the other side that we have today is Dima. He is as well a QA in Vewd in the content suite team. So we got the challenge to actually prepare this Cypress test. We did like a small POC. We checked around and we decided that actually we liked it. So we started using Cypress as it went on. For today's agenda, we are going to be talking first. We will compare Cypress with some other frameworks, and we will say, like, why did we decide to start with Cypress, and after that to show you how it looks and how it works. Dima will present a quite interesting one about visual testing, and he will do a small demo over there. And after that, we will just talk a little bit about the problems that we have encountered, and maybe it will save someone the trouble of that. So at the end, we have our Q&A session, of course. And I wanted to say that this will be most likely a presentation for someone that hasn't worked with Cypress and would like to try it. But of course, maybe someone that is working with it would find out a little bit more or share some tips. Okay, so we start. Let's start with the comparison. What do we have here? On the first spot, we have robot framework. What robot is saying is that it's a very easy one to be used. They use something called a keyword-driven approach. So basically, the files that you are writing, they are more like almost looking like a free text format, and they say that it should be pretty easy for someone that is non-technical to start writing those tests. But the cons of that, of course, when you write if you would write something like that, the whole tests are getting a little bit big, and after a while, it's a little bit hard to manage. So, yeah, that is one of the cons. And when it comes to another con, it's actually is it possible for non-technical person to write automated tests, and should they? So this is more like a question. It's should we do it? Because after all, automated tests might need to be written by people that are proficient in that. Okay, so next we have Selenium. When it comes to Selenium, it's a quite a known framework for automated testing. It's been for quite a long time around. It's having wide range of supported languages, has a huge community. It has a lot of plugins that can do all sorts of things. So basically, you can do almost anything when it comes if you select Selenium. But of course, it is pretty big, and with that also come some cons too. So over here, people that usually say that about Selenium is that the setup is a little bit more complicated. So with the more complicated setup, and also we have the manual weighting, which is creating flaky tests. Sometimes you don't know for how long you should wait, and so forth. So it really can be a trouble after a while. So then we are having Cypress, which is the tool that we will be presenting today. And the pros when it comes to Cypress is that it doesn't use the web driver for executing commands. It's basically running like a node process and also is running the browser and executes DOM commands straight in the browser. So we have like some sort of a backend and front end in one package. So it's a pretty cool thing. And also, since it doesn't use the web driver, it might be slightly faster. And another very important thing is that automated weights, there are automated weights in Cypress. So that way we don't need to write manual weightings. Actually, manual weighting is even more taken as like an anti-pattern in Cypress. So with this, we are trying to avoid the async hell that can happen. But of course, always there are some cons in that. And considering these tests are using the browser and they will be run in the browser, they are using only JavaScript or languages that compile to JavaScript. So you wouldn't be able to write Cypress tests in Python. So also, when another con that can happen, and we noticed it in one of our projects, since we are dealing with smart TVs, it's kind of complicated to run it in, if not impossible, in some other machines. For instance, on a TV platform, it would be almost impossible to run it. But as I said, Cypress is getting very popular as the time is progressing, and as we can see, this is the popularity chart like from the downloads that happened in the past years, comparing Selenium WebDriver and Cypress. So we can see that it's getting quite popular, so we know that the community will keep on getting bigger, so that is pretty good for finding out some new solutions to things, and also we know that it won't drop support of it. So why did we pick Cypress? We already had some robot tests, but as I mentioned before, they already started becoming a little bit too big, and it was already hard to maintain, so we decided to go on fresh and check some other solutions that we could have. Also, there was the idea proposed that our front-end tests will be using a front-end language like JavaScript. So that way, it was as well easier for us to get like some feedback from our developers on why we should use something, how to use it, and it was pretty nice because we could get some code reviews and even get some tips on best practices on the whole thing. And the last thing was that it was very easy to learn because of the good documentation. When we started off, of course, it was a very big thing because we needed some sort of guideline on how to do it, and Cypress provided it pretty well, and we are very happy with how it went. Okay, so I said that Selenium was a little bit complex to set up. Then what comes to Cypress? How complex that would be? Well, when it comes to Cypress, setting up is super easy. All you have to do is use Node Package Manager, npm. You write the command npm install Cypress, and voila, we have Cypress already there. We just execute Cypress open, and we are already ready to use and run Cypress. Well, you can also use Yarn or direct download if you prefer, if npm is not your tool. Okay, so working with Cypress. We have two ways of working with Cypress. One is our GUI, the graphic user interface, or we have the console line interface, which we can use. On the left side, as we can see, the graphic user interface, it shows us a pretty nice interface with our browser version that we are having on our local machine, our tests that we are about to run, but also everything, all of this is available via using the CLI, and we can run it that way too. Once a test is run in Cypress, this is what we are getting. Browser pops up and it opens up. We have the command log on the left side, and we have the app preview on the right side. So on the left side, as we can see, it's the tests are executed. They're being shown real time what step is being executed, and on the right side, right away, we are able to see what is happening. Also, a very important thing to notice here is that this is actually a regular browser. We can open the DevTools, and it's very, very handy when it comes to debugging some problems. You can open the console logs, you can open the network logs, and just check what actually is happening in this browser too. So it's very handy when it comes to debugging. Okay, so there was one problem that Cypress faced, is like, this was all very nice, but can Cypress work in actually a very complex application that is out there? So the creators of Cypress decided to create something called the Cypress Real World App. It's an open source payment application that is basically showing the best tips, tricks, and patterns that Cypress is using, and the tests are run on this application that is out there in real time. It's very good for tinkering and seeing how Cypress works, and also to even check what kind of patterns they're using in order, for instance, to log in, which is a common thing in applications. So it's a great way to see and check out. Okay, so there is also one paid and optional feature from Cypress. This is the Cypress dashboard. It also has a free plan, and it's a very cool feature because What it provides us is it provides us a service complementary to our CI provider like GitHub, GitLab, or so forth. And in this way, that once our tests are failing, for instance, on our CI, usually we would need to go through our logs, and the logs are not very helpful. Not only that, they are very hard to read, and also sometimes we would like to get some data out of them, but as we can see, it's like a lot of logs and hard to get all of it. So with the dashboard, they are providing it a very easy service that we are able to see our test runs and to check them over there. We are also seeing that there is analytics tab. It provides a very useful analytics. So over there we can see all sorts of things like what kind of tests are flaky, which are the failing tests most common, where, how long does it take to execute it. So it's a very handy tool. So it's worth considering if for someone to check it out. But since it's paid, then how would we know if we actually want to get it? Here is one of the views. So this is what is happening if we would like to really check it out. This is a match from heaven, as we are saying. It's perfect. Here we have the real world app, which was this open source app integrated directly with the Cypress dashboard, and being available for everyone to see how the dashboard really works. So if we follow the link, we are able to see all of the runs, what failed, all of the analytics that are happening. So it's a very cool thing for someone that is willing to invest in Cypress and would like to check if the dashboard is something that they actually need. So I talked a lot about all of this stuff, so maybe let's run Cypress and see how it looks like in real life. I already have my project set up over here. So as I said previously, I will just run node modules, Cypress, bin Cypress open. And this will open up the GUI of our tests. What do we have here? So we have, as we see, our tests. And if we press on one of them, it will open up in the local Chrome version that we have. So I'll start with the first one. And we will see how this will look like. So everything starts over here. If something goes wrong, there will see an error. The left side is our command log. And shortly, we see that what passed and what failed. If we would like to see what has been happening, there is also this useful feature called time travel. We can open on that specific place, go over there, and we are seeing what actually Cypress was doing. So Cypress basically recorded all of it, and if we can also pin it, use before and after, and we can see up there that the value is changing. So we are easily able to debug it in this way. Otherwise, it will be much harder for seeing why something failed or what happened. Okay, so how does it look like in here? So basically, this would be our folder that the first time Cypress runs, it creates this folder. This is the Cypress folder. And inside of it, we can see a couple of other folders that are being created. Fixture is created automatically as integration, plugins, and support. Fixture is, of course, for the fixtures. In integration, our tests will go there. In plugins, here will go test cases that are needed for the execution of our node side. And in support, there will be some stuff that we want to execute before our tests run. And also, with Cypress, once we set it up, it comes a folder with examples. which is showing us all of these test examples that we can just simply go through, sometimes even delete and edit and so forth. So it's quite handy when it comes to working with it, and it's a good starting point for someone that would like to get their hands dirty with it. And as we can see here, this is how a Cypress test looks like. The syntax is basically the tests are organized like this. The syntax is they're taking it from Mocha. So if someone is familiar with Mocha, they would see it like something very similar to this. So what happens here? We are specifying our test case. We use sci.get in order to get this element. We will type whatever we inputted there, and we are using an assertion, and we are checking whatever was happening. So this is how the tests are looking like. It's nothing very complicated, and yeah, basically that is it when it comes to it. What will be next is Dima. We will go back to Dima and his presentation, and he will go on with the visual testing that he has seen. So Dima, please go on. The screen is yours right now.
Okay, thank you, Christian. I'll try to do my best. I saw that I already had the spoiler to my part, so you are everybody surprised what I will be talking about. Yeah, so I'd like to talk with you about, hello everybody, I'd like to talk with you about the visual testing. What is it, why do we need it, and do we need it or not? So as the title suggests, this test is related to visual, how your application looks like. And the simplest definition you can see here, basically this is the same application, this is the same page, but the left one has attached the CSS files and the right one doesn't. So in case of functional tests, probably they will pass as you will start to click in the tabs, so you start to fill in the fields, or you will start to submit the forms, and everything will work for you. But try to imagine if it would be the Facebook or kind of those applications, and you will need to use this application which looks like this. Even if the value of this application could be big, I probably think that you will not use it. Yeah, and visual testing is basically how your application looks like, and the main goal of it is to catch the regression of your of the view errors. For example, if the button moves a bit to the side, or if the colors changed, or the justifying is wrong. It's hard to verify if you will start to do it manually. You just simply not catch it. That's why that's basically what the visual testing. And to catch this kind of problems, you have two options to do. The first one, you can start to, in your automation, you can start to verify each property of each CSS property of your page. But try to imagine how much thousands or hundreds of properties you have on the same view, on the single view. So I believe that quite soon you will understand that you can't maintenance it, as you will start to check the color, the size, etc. And that's the bad solution to do. So the right one is more to going to start comparing the screenshots. So the idea of it, you have a sample of your page, you have a screenshot of it, and each time you run your tests, the new screenshot will be taken and be compared to the first one. So if something will be changed, if something will be different, then the test will fail. And the important stuff here, that Cypress itself doesn't support visual testing. It only allows you to take a screenshot. So there is no comparison logic for screenshots. That's why in our tests, we used the Cypress image snapshot library. This is a plugin for Cypress. And Cypress has, I think, around 10 or so plugins, the third-party plugins, which allows you to do that. And here on the UI, on the screen, you can see now that at the left part, we have our sample. By the way, you don't need to do it like manually to start creating these samples. All you just need to run for the first time your tests, and the screenshots will be created automatically, and they will become your samples. And if something will broken, if something will be changed, then this library will create the image like that. So at the left side, you will have the snapshot, your sample. At the right side, you will have the actual screenshot. And in the middle, you will get the difference. So you can simply see what changed here. Okay, and I'd like to show you a small demo here to show how simple it is, or not simple, we will see. Okay, I have 5 cases here created for visual testing. And each of them, basically what you need to do, you need to call this after installation library, you need to call match image snapshot method. And as the first parameter, you need to pass the name. You need to pass the name of the file. So what screenshot will have the name for specific page. And the second parameter is optional here, and this is option how this screenshot should be taken. But maybe we will talk about it a bit later. So after the first run of these tests, you will get you will have the folder snapshots, and inside of it you will have images. As I had 5 cases, I have 5 images here. And the first one, there is a couple options how screenshot will looks like. The first one is a full page, and you can see it now here. So the Cypress, while it takes a screenshot, it go from top to the bottom and take one long screenshot. The second one is a viewport screenshot. So then it will be taken only the viewport screenshot. It will not scroll down. And the third one was the runner screenshot. So you will see also the log on the side, as Christian showed. The good option here also, if you don't need to compare whole screen, you can just get a specific element. So this basically this test taken a screenshot of specific element in a DOM, and you will get in my case it would be like you see now this image. So you can specify what element of DOM you would like to take a screenshot. And the last option here, which is really valuable, what if somebody, what if your fields or part of your page is dynamic? I don't know, you have a clock on your page, or you have a fields which has different text each time. With this library, you can black out the field. So you can just specify what elements you would like to black out. So you will still be able to test how it looks like, but without specific elements on there. And to do that, you just need to be coming back to this optional object we pass as a second parameter to this library. And there is a property blackout, which basically getting the list of selectors which you would like to black out. Yeah. And now I think we can run it and see how it works and what is going on during these tests. We can see now how it scrolls down, how it takes the screenshots. Takes a few seconds more, I believe. Okay, so now we see that all tests pass. Okay, but we can do that they will fail, and we will see how the results will occur on our display. So let's imagine, let's take this one with blackout, and this is the sample, as I told. So now I will remove just this blacking out, so new screenshot will not have those black field. And after this, okay. And after this, Cypress will notify us that something happened, and then it will create a screenshot, create an image with these differences on the page. Okay, so the last one, as expected, failed, and you get clear message that the image was 14% different from saved snapshot. And you can also have the pixels value here, depends what you want. So that's how this visual testing works. So you just need to write few lines of code, sometimes more, of course, and it's quite simple to implement. But of course, not there are underwater stones. So we would like with Christian share with you problems we met during implementation of our functional visual testing also. You know, the real life is real life. So Christian, I am giving back your word, and you can go with problems you met, and then I will come back with mine.
Okay, so we are going back to the troubles that we met along the way. But first, I would like to reply to one of the comments I got. I see that what is the best way to start with Cypress? So it really depends on what your preference is. If you are a person that likes to read more documentation, then you can really go with the official documentation from Cypress. But if you're a person that likes to practically learn, like me, so that way it would be better if you simply just start using Cypress right away. Use this npm install Cypress and check out the test cases, go through them, and in the test cases they also have in comments some more information, and also where links to where you can learn more about it and what you should put where. So yeah, you have both options, and you can use the documentation for that as well. It's very useful. Back to the troubles that we met. So the first problem, if you decide to start using Cypress, is the approach that they're having, and this is programmatically logging into your application. So what basically does this mean? Cypress is saying that it's an anti-pattern if you're using your UI to do the whole path in order to build up some sort of state. Like in this case, in order for logging in, we need our cookies, and there is a much easier way, and we try to avoid using the UI as much as possible here. So we are trying to build up the state without the UI. A little bit similar to how the API flow tests were working previously. So this is what Cypress is recommending. So what do we actually do is we are sending requests, and we set up the cookies for the browser, so later on the test will be able to use it. Thankfully, this is like a very common problem, and common approaches are already recorded and are already put in the documentation of Cypress for different types of authentication providers, whatever it's a third party or so. So if you decide to go with Cypress, this will be probably one of the first major issues that you will see. Next, what I have noticed was I told previously that it's running both on backend and the frontend, and I just decided, okay, then I will use a node to get some package, and I will just simply use it to, for instance, as in this case, to remove one file. So I ran the test, but I got into an error. So I was wondering, why doesn't it work, and why am I not able to use it in this way? So basically, it is not working like that. If you decide to straight up use the package, then you will have a problem. You can't simply use it in this way. In order to use it, you need to use the command cytask. So, and here is where this plugins folder comes in handy, and all over there we can input some sort of methods that we can use that can be forwarded to be used by the node on the backend. So then it will run that sort of a command, like in our case, the removing of the path. And this way, with the cytask, we just name the command that we need to execute. Cypress from the browser is sending the request to the node side. and it's being executed, and this is how we would be able to remove something. Okay, so my other problem was the order of how the Cypress commands were running. I really had a lot of troubles with this. As we can see, it made me even cry, in some in sometimes. So what I was thinking is that actually here we will execute everything from top to bottom. So our scget will run first, scywait after that, then some code not using Cypress will be executed. But everything was so jumbled up. It was up and down. Everything was all over the place. I really didn't know what actually was happening. So Dima just mentioned it to me, gave me a really nice tip, and after that everything was very clear to how Cypress was running. So what Cypress is doing is basically it's ordering all of those commands. So first of all, the JavaScript code will run, and if we have any JavaScript code in our test cases, that will be the first thing that will run, no matter where it is. Is it the first or the last in the test? That will be the first thing that it will run. And but after it runs, Cypress is basically ordering all of the sci commands to be run in a synchronous order, one by one. So first it will be the in our case it will be the method that is not using Cypress. So basically it's just JavaScript code that will execute first, and after that we are able to see it will start with sci.get, sci.wait, and then we will run all of those other Cypress commands, because all of them will be ordered in a nice way. And in case we want to use to basically to order in such way some of the JavaScript code, we can use sci.wrap. We wrap this code, and then it will be executed in the manner as we would like it to. So these are the problems that I have met. I will try to give up to Dima and to the problems that he has met right now, and to what he saw there.
Yeah, sure. So a couple problems from my side. The first time I started working with Cypress, I was surprised that there is no async await functionality. So this is stuff from modern JavaScript, and Cypress clearly say that they don't support in their documentation it. As for this example, it's not a problem, as it's still a couple lines of code. So then I had a bigger case where I had a couple more methods stuffs to load. And if it would be nice, if it will have this async await functionality, then I just can create multiple variables and assign to it the results, and then nicely go with the code under these variables. But unfortunately, I need to start using nesting and resolving with this then function. So yeah, you can imagine that if you will have couple more, you can simply just go out of the screen. Yeah, but this is the way how it should be done, and there is no option with async await. The second problem I met, that was content sharing between methods, and the first I saw was start to using global variables, like to declare the variable, and then in one method to assign value, and in another use this value. This is example from Cypress documentation, by the way. Yeah, but this is a bad practice, and instead of that, Cypress suggests us to use aliases. This is the functionality they deliver. And when you load something, and as Cypress is asynchronous framework, and there are a lot of stuff that works asynchronously, we load our fixture and then assign a name to it by s function. And in next method, we are going and call by get this our named fixture. Be careful, we need to add symbol here at the beginning to be able to load it. Yeah, so that's how it should be handled if you need to share context, but take in mind that you can't share data between test cases. So you can't share this data between two IT methods, as by definition, this test must be independent. Yeah, exception here is before and before each method. context assigned inside it, available in all IT methods. Okay, so the next topic is the fixtures in Cypress. So I had a fixture like that, and I loaded as it asynchronously loading. I load it like that and resolve it there. But what if I need to reassign the values of it, like change the name of the of something? Then we simply need to overwrite it inside this then function. And that's the way how it should be done. There is a trap in case of file extensions for fixtures. Cypress told us that they support around 10 or 15 file extensions like txt, JSON, CSV, etc. And one of them is JavaScript file. So first my move was try to put here a function to do something. And no, in these files, unfortunately, we can't place any logic. We can't put their functions or so on. All what I did is export the array, and it was possible to do. There is a topic on GitHub about it, and you can read why it's not possible, and it looks like this is the bug. But for now, it's not possible to run here functions inside this file, which you load as a fixture. Okay, and Christian told about this login under the hood. So if you would like to send the request, Cypress allows us to send the request, HTTP request to the server. And that's how it looks like. So we have method, URL, headers, body, and reaction for this request. But what if our request will fail? How we can retry it? Can we do it or not? Basically, this is some kind of limitation in Cypress. They give us two possibilities to retry the request. The first one on network failures, and it's by default turned on, so we don't need to configure it. And the second one is retry on status code failure, and by default it has value false. So if you would like to retry a request on 400 errors or so, you need to override this value. And here comes limitation about the numbers of the retry. This is the first one, as they allows us to retry it 4 times. You can't overwrite it and say, okay, let's retry it 10 times, for example. No. And the second one, you can set the delay between the requests. So this request will go one after another. To override the value, to override the property, you can see how it could be done. We just, there is nothing special, basically. Okay, and coming back to visual testing, and does it have problems or not? And in my case, it had. As for one moment, I tried to test this pop-up in our system. And when I ran it, I saw that when I ran my test, I saw that there are some differences. Yeah, when I look on those image which created after the fails, I see that I have dynamic fields here. So the value of this field, of course, I did it on my own specially to show it during the POC process. But yeah, let's imagine that we have dynamic fields, and I decided to solve it by blackouting this field. So I will still check the model, how it looks like, how this pop-up looks like, but without the inputs here. After my blackouts, I saw something like that. So it blackouted me not what I want. When I start to investigate it, I saw that this is problem with the scrolling, and you can see at the right how it takes a screenshot. It takes screenshot during the scrolling. So could it be solved or not? I found the workaround and took a screenshot with viewport, so other type of screenshot, and it blacked me out. But yeah, there is a topic on GitHub for this problem too in Cypress. This is a problem with Cypress screenshot, I guess. And I also put here some links to tutorials or library I used to this visual testing, so it could be also interested for you. So yeah, it looks like I will close this party with the summary we have. Let's talk a bit about what we hear today. So Cypress, it's a new framework, but it's already mature. So there is a big community which work with it already. It has really good documentation. So you can go there, dive in, and there is no problem to understand how and what you should do. Yeah, but you know, until you met the problem, nobody read the manual. Yeah, so yeah, we know about it, and maybe we did less mistakes if we read it better on the start. But but documentation is really clear, so don't worry about it. The key value of Cypress is that we don't need manual waits anymore. So by default, it waits for some time, for timeout. And so it's really good for a modern web application when something loading dynamically. So it will wait. And you can, of course, override this timeout if you need more or less. Cypress dashboard. Okay, so this is good stuff to see the results of your tests. And the last one is about visual testing. Like I wrote here, it almost worked there. For some use it works, for some doesn't. You can try to do workarounds there. But I think Christian will agree with me that Cypress is a good stuff to start working with, and don't be worried about it. That's all from my part, from my side. Here is a quite funny slide from Christian, and if you like the Cypress, and you can maybe next time be between us in Cypress community. So thank you for attention, and here's the questions Q&A section if somebody has or no. I don't see any, so I don't know, Łukasz, could you confirm that there is no one, or?
Yeah, I can see that in comments section we don't have anything. There were a couple of people asking where they suggest to start learning and reading about Cypress, but I guess you already mentioned that it's best to start with the official documentation, right?
Yeah, official documentation or the examples, always pretty good and handy.
Cool, great. Thank you, guys. Thank you a lot.
Thank you very much as well for the opportunity.
Our pleasure. Yeah, so we have everyone here. So let me switch into Polish for last couple of minutes. To chyba tyle na dzisiaj. Bardzo się cieszymy, że mogliśmy być znowu z Vewd. Co prawda w takiej trochę zaburzonej rzeczywistości. Trochę gratulacji, widzę, że jeszcze spływa w komentarzach do wideo. Nagranie będzie dostępne na naszym kanale. My zapraszamy na kolejną WrotQA już za 2 tygodnie, 14 lipca. No i to chyba tyle. Dziękujemy Wam dzisiaj za Wasze poświęcenie w przygotowaniu, za pracę, trud włożono w przygotowanie dzisiejszych prezentacji. Bardzo ciekawe tematy. Jeżeli kogoś zachęciły, no to pewnie spodziewajcie się, że zapuka do drzwi Vewd, bo zobaczył, jak fajnie się u Was testuje. I tyle. Tyle od nas. Dzięki, że byliście.
Dziękujemy.
Dziękujemy.
Dzięki.
Dzięki wszystkim. Cześć.